A little bit about myself. I am a sales engineer here at 7Signal. I've been here, I think, about 7 years actually, working on 8. And I have been designing, installing, troubleshooting wireless networks since before Wi-Fi. My first networks actually were in the 450 megahertz LAN mobile band. So I've been doing it for a few years. Today we're talking about, really this is based on a paper that's downloadable from our website, one of our earliest papers, and it's still one of the most downloaded, I understand. And we're really talking about built-in antennas for access points or small, medium-sized omnidirectionals. You know, this is, we're not really going to talk a whole lot about directionals, that sort of thing today, but we've really come up with 3 sort of broad principles for locating omnidirectional antennas, and we're going to talk about some ways to install them that violate one or more of these principles. First one is they really perform best in open space. Omnidirectional antennas, built-in antennas, and access points, really they like to be clear of walls, clear of obstructions. Also, given that they are omnidirectional, they are generally best located near the center of the coverage area. So you don't want to offset them in a corner of the room if you can help it. And the third one is, and really applies to all antennas, is put the signal where the clients are. Doesn't help if you're covering spaces where clients are not, whether that's up in the ceiling or outside the building or whatever. How do those sound, Jim? Pretty good principles?
Yeah, they are. Particularly the last one. You know, when I do a design, one of the things I like to think about are where are those areas in the floor plan where people are going to congregate. Is there a big conference room, an auditorium, anywhere where there's going to be a lot of people? And I want to make sure there's an AP in that space, not 2 walls away, but providing, you know, good enough coverage, but right there with them, so those clients get really, really good SNR.
Yeah, absolutely. And I've come up with a few kind of categories that violate those principles in one way or another, and why they're bad, and we're going to take a look at these next 10 things not to do in terms of those. But you know, they're things that will disturb the or that will make for a non-optimal installation. And the first one is that if you have an antenna close to something, particularly something conductive, it will tend to change the resonant frequency of the antenna so that it's no longer tuned for the 2.4 or 5 gig, or coming soon the 6 gig band. So really that's part of that they like to be in free space. The other is that they will change the pattern of the antenna. So instead of being omnidirectional, it will be something else. And sometimes that can be a little bit hard to predict what that pattern is going to end up being. It's going to depend on the distance from it and the shape of the objects. But I actually did back long years ago a lot of testing with, in this case it was 2.4, but the same principles will apply to 5 gig. You know, how far from a metal light pole or a steel wall can you put an antenna, an Omni, without really messing up the pattern? And what I found is that if you can stay 2 feet away, that is really ideal for keeping that nice, clean omnidirectional pattern. And you know, maybe you can push it to 18 inches or so. And then, of course, with 5 gig, those numbers are a little smaller due to the shorter wavelength. The other problem, and we talked just a moment ago about putting the signal where the clients are, is that wasted signal effect, where you're covering the area above the clients, or you're covering hallways where really there are no clients. That sort of overlaps into the signal where clients are not. And all of these are somewhat related. The other big issue, and you see this particularly in larger installations, is increased self-interference with each other. If you have the ceiling, the access points or the antennas up in the ceiling, usually there's a couple of feet of clear space below the ceiling that propagates very well. So access points up there are going to hear each other better than they're going to hear the clients, better than the clients are going to hear them, and you'll get more interference. And finally, obstructions, where we have some sort of object between the access point and the client reflecting or absorbing the signal. So moving on to our first slide. And over here on the right, you see sort of the classic drop ceiling with pipes and ducts above it. And I don't actually see it right now, but if you look closely enough, somewhere there is an access point up in all of that mess. And, that's really going to change that signal pattern. It's not going to propagate evenly in an omnidirectional fashion. And it's going to be kind of hard to predict where you're going to get coverage without actually going out and measuring it. It also can, change the signal path and cause lower data rates. And really, you've got the reflection problem up there. You've got obstructions up there, and all that metal is going to detune the antennas as well. So I'm sure you've seen some installs like this one, Jim.
Yeah, unfortunately so. And it's, it's a matter of convenience. This is where the AP is supposed to go. So let's find somewhere where we can kind of tie it up and get it out of the way. So it's maybe not in that photo, but in other cases, just, we don't want to see it. We have aesthetic concerns, and, we're not aware of all the RF penalties we pay for doing that. So see that too much, but yeah, really want to bring those APs down below that ceiling grid.
And not only is it bad for the network, it's a maintenance cost as well, because when you have to go find that access point, it's going to be a challenge.
I've had that challenge. I've supported networks where not only were there APs, up in the plenum behind ceiling tiles, so they were invisible, but the network operators, the owners, were unaware that some leftover APs from the previous AP install were still up there and active, because they're invisible, they weren't well documented. And during a site survey, we discovered these extra APs in areas where we didn't see APs that were in fact internal APs connected to the the corporate controller. So a lot of problems can come from that.
I've seen that too, and nobody's quite sure where it's plugged in, or what's plugged in on that switch, so they're afraid to unplug random cables from the switch. And
yeah,
it can be a mess.
Yeah, maybe you can get that AP to broadcast a special SSID, or if you can find it on the controller, pull the CDP info from it and just turn off that switch port or unplug it there and leave it up there.
Yeah, I've actually even had situations where I had good drawings of where it was, and still had a challenge actually locating the access point.
Yep.
The other one, and Oddly, I'm not sure why, I see this one in hospitals a lot, just walking down the hall, where they'll just lay an access point on the top of a ceiling tile and poke a couple of holes in it for the rubber ducks to poke through. And it's not good for the antenna tuning to be pushed up against those metal rails at all. And it kind of gives it a little bit of an amateurish look as well, I think. I know you did. You have a hospital background, Jim. You ever see those?
I have, and it's a little bit perplexing because, like you said, it really looks like a amateur install, and if the thought was we're doing this for aesthetic reasons, so the AP itself is hidden, I don't think it's executed very well. I think,
Yeah,
just from an aesthetic perspective. So,
and as I said, it's not good. I guess I'm going to say that if you just can't help yourself and you're going to do it, at least put it in the middle of a tile. See this a lot as well, and where you've got an antenna mounted up against a wall or some structure, and really it's gonna, as we talked about, it's gonna change the tuning on the antenna. You're covering probably areas behind that wall where you don't need the signal. Really, this, if you can't put the access point in the middle of the area, then maybe it's an occasion for some patch antennas instead of the Omnis.
Yeah, this could be worse. Yeah, at least it's not using internal antennas here, which we'll see in a future slide, but not ideal. Sending a lot of signal into that wall, and depending on the wall material, right, we could have a detuning effect. I forgot to mention too on the last slide, if you just want to go back for a second, there are options from some of the companies that make AP enclosures just to replace the whole ceiling tile with a nice flat looking unobtrusive enclosure that it's a proper radome. It's got the AP, a mounting slot for the AP, and then the antennas just kind of stick down from that. But the RF is treated much better in that case, and visually they look so much better than this. So
yeah, I like the ceiling enclosure solution as well. It accomplishes a lot of things. It looks better. It physically secures the access point if you have any concerns about it walking off. And there's a wide variety of styles available. So if it's an internal access point, as you said, there'll be a radome that the access point can kind of hang down into. So it's in clear space. And some of them have mounting holes drilled in if you want to use your own antennas on the external surface, if you want to add a little more gain or something. So yeah, absolutely, big fan of ceiling enclosures, and it makes the maintenance so much easier. You don't have to open up the ceiling if you've got dust concerns or something like that. And I think we talked about that one. And this one, we talk about this a lot, and we see it a lot in commercial buildings and warehouses where you have an access point mounted well above the users. You're putting the signal up in the ceiling, so you're wasting the coverage. You're putting the coverage up in the ceiling, so you're not covering where the client is. And because that's free, clear space up there, the access points are all going to hear each other very well, and will tend to self-interfere. And on that self-interference, remember that, and it's particularly true at 2.4, where we've only got 3 channels to work with in most of the world, those access points are going to be responding to all the probes of every device that walks by. So if you're in a particularly public place, they're getting sometimes hundreds of probes a minute just from people's phones and Wi-Fi enabled watches and other wearables that are out there looking for an access point to attach to. And if they hear a probe, they're going to respond. So a lot of potential for that self-interference up there where they hear each other so well. The next slide is really a variation on the theme. I usually see it in even larger buildings where, if you can tell, if I can get an arrow to pop up, we've got some omnidirectional, some higher gain omnidirectionals mounted external on that access point. So it really makes the last slide even worse because you're adding more gain to the situation. You're holding the signal up at the ceiling. Just makes it all worse. I'm sure you've seen this a lot too, Jim.
I have, and it does make it worse because the higher the gain in those omnidirectional antennas, that usually affects the coverage pattern, and that sort of the disk of coverage horizontally that comes out of the antenna gets narrower and smaller and smaller, and actually further away from the floor. So not a good design.
No. And if I remember, the next slide kind of addresses, a couple of solutions. So, we've just told you that don't do that. So a little bit of what can you do? And the first one, I've seen this in a few places, and I think it looks great in a commercial building. I really like the solution where you just drop a piece of conduit from an electrical box mounted in the ceiling or mounted on one of the ceiling joists, and drop the access point down closer to where your clients are. It gets it in free space, it gets it closer to the clients. If you've got a concern, if in a warehouse situation or something of it being hit by forklifts, you can replace that conduit with cables and give something that'll just move out of the way if it gets hit. So that makes for a great kind of warehouse solution where you're trying to get the APs lower, but you're worried about them getting hit. And on the right, we have sort of the solution is to move away from those omnidirectional antennas and go to something directional on a wall and fire in towards the center of the building. You like these solutions, Jim?
Yeah, I love them. I like seeing those internal antenna APs hung from conduit like that. That's a really good and cost-effective solution, very simple and solves a lot of problems. But then in, say, a warehouse design, the wall-mounted patch antennas firing down the aisles, for example, that's really, really effective as well. So
yeah, that's the classic. And of course, it doesn't have to be down the aisles. It can be firing into or down the line of shipping docks or something like that in a warehouse as well. So yeah, I really like both of those solutions versus access points up in the ceiling. Number 6 is that you've got an access point near a wall that's going to obstruct coverage into the nearby room or the outside of a building even. So we did a little coverage pattern here to sort of give an idea. And you can imagine that if we were to shift that to the middle of the room, we would be able to cover that entire room pretty much with one access point, whereas now it's definitely going to take at least one more over in the other side of the room and probably several more. So I think that's just that. Try to put them near the center of the coverage area. They're omnidirectional. They cover in more or less circular patterns.
yeah, and so this is one of those kind of guidelines. Sometimes you violate it because you're doing location services,
Oh yeah.
right? And that's one of the things where you have to really compromise on what's best from a Wi-Fi performance perspective, and well, what's going to give me the best location accuracy if I'm trying to use Wi-Fi for RTLS? Because one of those design principles in that case is put your APs around the perimeter of the building, and you end up with all this signal just firing into walls and not getting the best coverage you could from the AP. So it's one of those compromises that sometimes we make.
Yeah, absolutely. And we talk a lot about put access points here and don't put them there. And in carpeted spaces, offices, a lot of times you've got a lot of flexibility, but as you move into more industrial spaces, warehousing, a lot of times you're very restricted on where you can actually put an access point, and you have to just do the best you can. Here's the one that I think you were talking about as upcoming, where we take a access point with an internal antenna, and I can't remember where I pulled this coverage graph from, but it was actually something I pulled from an internal antenna on an access point, and overlaid on top of our access point. But we can see there that we've got gain along the surface of the wall, up and down and sideways, and pointing out towards the room, we actually have a little null in the pattern. So it's rotated, basically 90 degrees from where it's designed to be installed. See this one a lot too. It's I think the mounted along the wall, but without an external antenna effect. Is this the one, Jim?
Yeah, that's the one I was thinking about. And this isn't the worst thing in the world. Again, it might actually meet the requirements for coverage in a small area, but you're definitely wasting signal firing upwards and downwards. And there's sometimes this comes about out of a matter of convenience. I've got my Cat 5 right there on the wall. I'll put the AP right there. It's an extra step, would make it a lot better if you put like a right angle mount, so at least the AP was tilted 90 degrees. You're still sending a lot of signal into the wall, but then at least the rest of the coverage pattern is improved. And then, like you mentioned, Mike, you could use external antennas, pointing vertically out of the AP, which would give an improved coverage pattern as well. Or put them on the ceiling.
Or put it on the ceiling, absolutely. Or, that bracket is a great idea. A lot of manufacturers do sell kind of right angle wall mount brackets that'll let you flip them, and it'll stand it off from the wall a little bit as well, which is always a good thing.
Yeah, it's a better option if ceiling mounting is not possible.
Yeah. I don't see this a lot. I used to see it more, I think, but it's the painted antenna, and usually you're okay as long as it's a water-based paint and it doesn't have any metallic elements in it. But there are some paints that will affect the resonant frequency of the antenna that are somewhat conductive. I think that if you have to paint the antenna, then at least get one and do some tests, painted versus unpainted, and make sure that it's not affecting the pattern or the resonant frequency of the antenna.
Yeah, and you might. Yeah, sometimes the antenna manufacturer might have recommendations on specific paints that they have found in their own testing are safe to use. And sometimes there's a desire to paint an AP with internal antennas. I've seen that quite a few times, particularly in areas where, they want them to be unobtrusive in a dark area. They just want to have black APs, so they kind of disappear. And in that case, there's a few companies that make like pop-on skins for APs that can be different colors. Usually dark colors are desirable, that are made to be, RF friendly. So
Yeah,
those are
I've
options
even
as well.
seen like a vinyl wrap sort of
Yeah.
material for antennas. Really, it was intended for big panels, make it look like a brick wall or make it look like a wood shingle wall or something like that. For really, I think it's targeted at the cellular industry, but there's no reason that you couldn't use it as well in the Wi-Fi world.
Yeah, for sure.
I love this one. I've actually seen this, totally not kidding, where you take the client device and you put it in a metal box, all sealed up, and yeah, that really does not work well at all. So if you have to seal up your radio, you're absolutely going to need some external antennas on that box.
Unfortunately, I've seen this too. It's pretty ugly. It's kind of amazing that it works at all. When you've got a Wi-Fi radio inside with the antenna inside a metal box, and of course the way that problem report comes in is there's a problem with the Wi-Fi network, right? But this is a client, client issue. Hopefully, that enclosure has. Yeah, I was just saying. Hopefully, that enclosure has a port where you can put an external antenna there.
Yeah, that's really the right solution, I think, is to put an external antenna on the back of the enclosure or the top of the enclosure.
Yeah, the only risk there is with mobile clients. Sometimes those external antennas get broken off. Unfortunately, I've seen that before too. But
yeah, I've seen that several times actually in the computer on wheels kind of thing in a hospital, where they might have little rubber ducks hanging off the back of the cart or something, that when the carts get parked, those can catch on objects. So I've seen that several times. And then finally, and this one isn't so much of an access point or an antenna issue. It's more of a planning and survey issue. And this one specifically is talking about VoIP phones that you're holding up against your head, you're covering with your hand, and that's going to soak up a lot of energy, and it's going to give a lot different reception characteristics than if you did a site survey with a laptop, perhaps even with an external card or a USB adapter or something hanging out in free space. And I think the point here is just to remember, whenever you do site surveys and when you plan the networks, to give some thought to what the clients are going to be. And if you can, survey with a client device. If the client device has any kind of signal strength tool or something like that, use that in addition to your normal survey tool to verify that the coverage you think you're getting, you are.
Yeah, definitely. The instruments that we conduct site surveys with are very sensitive, and usually don't have the same compromises built into their antenna designs that particularly smartphones do. So it's always good to look at that survey, and if you can, if the software allows you, apply an offset. Sometimes a big offset, like a voice over Wi-Fi handset, might have, 10 dB, might be 10 dB less sensitive than a site survey rig. So if you can apply that to get a rough idea to your design of what that client will see, that's really helpful.
Yeah, absolutely. And it's one of those, it can certainly present as, these devices don't really work very well. And it's not so much the device, it sometimes actually is a network problem. You just didn't design enough coverage in for those devices. And I think that is it.
Great. Yeah, thanks, Mike. Great presentation as always. And we do have some good comments and questions coming in from the audience. And I want to welcome anybody else that has questions to drop them in the Q&A panel now. Couple comments from Stephen, just sharing a little experience. He says, with APs mounted horizontally on the wall, he says it used to happen a lot in our company, but it killed coverage floor to floor and caused significant roaming problems. It's an absolute no for us, completely against our principles based on experience. So interesting. In some designs that can really cause some serious issues.
It can, and it's better now, and by now I mean post 802.11n, where we have MIMO. That really improved that situation. But with the old 802.11 ABG access points, that kind of stuff was deadly.
Yeah. So a lot of interesting comments and questions about ceiling tile enclosures, questions about options from companies like TerraWave and Oberon, and people wondering if there's any good, if they're any good, do you pay any penalty from those? I think, from the networks I've seen that use those, when used appropriately with the vendor recommended ceiling tile for the particular AP you're using and antenna configuration you're using, those tend to be pretty good in general, but definitely work with the vendor to make sure you pick the right one.
Yeah, I agree. Of the people that I've talked to that are using them, I've heard mostly pretty much happiness from them. You do need to make sure that if it's a radome type enclosure, that you've got the right mounting brackets and stuff so that the access point actually hangs down, up against that radome. But yeah, they work well, I think.
So here's a question from Bruce, and he says, for outdoors, when trying to cover rail tracks right next to a building, do you have a concern with installing an Omni against the outside wall, knowing you need coverage directly below and not extending out into the yard?
I mean, technically, yeah, there's a null there under that antenna, but you're also really close to it when you're right under it. So, inverse square is working in your favor in that case. So, I would want to mount it on the antennas on standoffs from the building. I wouldn't want to mount them flat up against the building, but I think you're probably going to be okay there.
Yeah, I think so too. I mean, the other possibility is maybe use a patch antenna, but that may give too tight of a coverage area than what you want. So kind of depends on how wide you want the coverage. Although there are some patch antennas out there that get pretty close to 180 degrees. So
yeah, you could definitely use like a wide angle sector and give it a whole lot of down tilt if you need coverage right up against the building and not at a distance. Those are going to be more pricey than a basic Omni, though, a lot more.
yeah. Question here from John. He says, what about The client-side antennas. Have manufacturers made improvements to work in favor of some of these less desirable conditions?
I think I'm kind of a pessimist on client device antennas. Some laptops do pretty good because you've got the big frame for the screen that you can wrap an antenna around, but smart devices and VoIP phones and those kind of things, and the antennas are usually just horrible.
They really are. Sometimes they have negative gain. I mean, they're so compromised to fit in smaller and smaller areas. Even though smartphones have gotten bigger and bigger, that hasn't been to make space for better antennas. It's been to, put all the other stuff that hardware they want to add into phones as well. So, and then you get into IoT stuff, really small things with, built to the lowest possible cost. And you're right, tend to be pretty poor performers.
Yeah, those IoT devices, some of them are astoundingly bad. They're not only have a tiny terrible antenna, they're probably a single stream device. They're going to be really low power. They're going to use the cheapest possible chipset. Some of them are pretty bad.
Mm-hmm. And one last question from Charlie, I think here. Interesting question. He says, do you ever consider the use of bandpass filters in high density environments in close proximity to other APs? Thanks.
I have used them in big outdoor installations. I don't think I've ever used them in an indoor high density installation.
Yeah, and that's between the AP and the antenna then?
Yeah.
To prevent some, carryover between bands? Or,
yeah, and I've never, some adjacent channel rejection in there.
Mm-hmm.
I've never used them in 5 gig either. I don't know if there are bandpass filters that narrow at 5 gig. I've just never looked, but I have used them in kind of dense outdoor 2.4 environments where we had a lot of interference, and they help a little bit.
That makes sense. Yeah, at 5 gigahertz, we have the option of factoring that into our channel plan a little bit to mitigate some of that.